Hey everyone, welcome to this explainer. Today, we're diving into the source material to unpack the absolutely fascinating cosmic partnership between the Sun and the Moon. If you're into space and the mechanics of our universe, you are in the perfect place. We're going to break down exactly how these two massive celestial bodies pretty much write the rules for our entire solar neighborhood.
So here is our roadmap for today. We'll start with their fundamental identities as the two pillars of our sky, move into the mind-bending game of size and gravity, track their journey of time through space, and finally, look at their delicate impact on Earth.
All right, let's jump right into Chapter 1, Two Pillars of the Universe. Let's establish exactly who we are dealing with here.
First things first, and it's a crucial distinction. Our Sun is not a planet. It is a star. It's the single, solitary anchor of our entire solar system. Every single planet in our neighborhood, including the rock we're standing on right now, is locked into an orbit revolving entirely around this one magnificent, glowing body.
And the dynamic between the Sun and the Moon, it's like a cosmic study in contrasts, really. The Sun is this massive, active engine pumping out immense heat and brilliant light through its own internal fusion. But the Moon? It produces absolutely zero light of its own, nothing. Whenever you're looking up at a gorgeous, glowing full moon, you are literally just staring at a giant, silent rock acting as a mirror, bouncing the sun's radiant rays right back to us.
Moving right along to Chapter 2, the game of size and gravity. And let me tell you, the scales we're about to talk about are just mind-bending.
Get a load of this number, 1.3 million. That is exactly how many Earths you could cram inside the volume of the Sun. I mean, just stop and think about that for a second. Every deep ocean, every massive continent, every sprawling city on our planet, you would need to duplicate all of that 1.3 million times over just to fill up the physical space of our star. It is wild.
And if we're talking about mass, it's not even a competition. The Sun is the undisputed heavyweight champion of our neighborhood, holding a staggering 99.8% of all the mass in our solar system. So that tiny 0.2% sliver that's left over, that literally has to account for Jupiter, Saturn, us here on Earth, the Moon, plus every single asteroid and comet out there combined.
Now, let's flip over to the Moon. How does its physical presence compare? Well, lunar gravity is roughly 6 times weaker than what we feel on Earth. To put that into perspective, if you weigh 60 kilograms right here at home, you'd step onto the lunar surface and weigh a mere 10 kilograms. Talk about an instant ego boost, right? You would practically be floating with every single step. But, you know, there's a serious catch to that incredibly weak gravity. It means the Moon cannot hold on to an atmosphere. And without an atmosphere, you get this terrifying silent void. Since there's no air for sound waves to travel through, you could scream at the very top of your lungs on the lunar surface, and it would be met with absolute unbroken silence.
Okay, let's shift gears a bit. Chapter 3, Journey of Time in Space, where we look at celestial motion and aging.
So, here is a question for you. Have you ever wondered why we only ever get to see one half of the Moon? Seriously, no matter where you live on Earth or what season it is always the exact same familiar face staring back down at you. Kinda mysterious, right?
While the secret is this fascinating mechanical lock known as synchronous rotation. Basically, the Moon's spin is perfectly synced up with its orbit around us. In the exact amount of time it takes the Moon to do one full lap around Earth, it spins exactly once on its own axis. Because of this perfectly choreographed dance, that far side stays eternally hidden from our view.
But that cosmic relationship, it's actually shifting. 3.8 centimeters. That is the distance the Moon is creeping further away from Earth with each passing year. Our closest celestial companion is literally steadily backing away from us right into the depths of space.
Meanwhile, as the Moon slowly slips away, our Sun is just showing off its incredible endurance. It flared into existence roughly 4.5 billion years ago, which puts it right about in its midlife phase today. It actually has enough fuel in the tank to keep burning and keeping us warm for another 5 billion years into the future. It is a stunning perspective on deep cosmic time. Which brings us to our final stop today. Chapter 4, Their Impact on Earth and the Delicate Balance They Strike.
At the end of the day, everything alive on this planet relies heavily on both of them. The Sun, of course, is our foundational engine. Without its light, heat, and energy, life just simply wouldn't exist here. But the Moon? It acts as this crucial mechanical regulator. Its gravitational pull is the primary driver of our ocean tides, maintaining a deeply vital, rhythmic balance across all of our world's waters.
So, knowing all of this,
especially the fact that our silent reflector is slowly drifting away, I want to leave you with a thought. As the moon creeps that 3.8 centimeters further out into space every single year, how do you think our oceans, and ultimately the future of life on Earth, are going to adapt as this cosmic dance inevitably changes? It's a huge question, and a powerful reminder that even the most permanent-looking fixtures in our sky are caught up in a constantly evolving universe. Thanks so much for exploring this explainer with me, and hey, never stop looking up.